Good evening, guys. Today in this lesson we are going to look at something called as a great circle. In navigation, apart from great circles, you do have rhumb lines and you do have small circles. Okay, but today for our interest we are going to look into great circles. Before we go into great circles, I need you to understand a little bit of concept. This is when I have 2 points on the earth, say point A and point B, the shortest distance between them will always be a straight line. Even if you go by a very small diversion like this is not going to be your shortest distance, whereas your blue line is going to be your shortest distance. Alright guys, so you see I'm using Google Earth to demonstrate what is a great circle. So here you have the equator, and then you have the northern hemisphere here, and you have the southern hemisphere here. Now let me take 2 points, point A and this is point B. Now you see this is a straight line, which is a shortest distance. Now let us see what happens if I extend this line as a straight line. So I'm going to keep extending this line, which is approximately a straight line from the above. So this is not a straight line. Let me extend it. Yeah, this should be approximately a straight line. No. Okay. This is a straight line. Okay. Now, yes, this is a straight line. This bends because of the curvature of the earth. Okay. All right. You see, this becomes a straight line here. I'm going to connect it again. This is a straight line as well. And yeah, I'm going to join these two places. All right, now let us see how the earth looks. See here, we started with these 2 points on the earth, point A and point B. So when you connect the entire lines, you see, you cut the earth actually into 2 equal halves. Now see, if you can imagine like this, see, this is one half of the earth and this is the other half of the earth. This is exactly what a great circle does. A great circle is something that cuts the earth into 2 equal halves. And the shortest distance between these 2 points will lie on a great circle. So as you can see, what I've done is I've drawn the great circle track as a red line, so you will clearly know which is a great circle track. Now if you see, the great circle track has cut the earth into 2 equal halves. You see, this is one half and this is the other half. So now what are we going to see now is how this affects your great circle track in the northern hemisphere and in the southern hemisphere. So when I'm going on an easterly heading, say from point A to point B, the initial great circle track is 42. Now further if I go east, you see the great circle track is now 46. Now further east at this place, it becomes 59, the heading. So the great circle track on an easterly heading increases. Now let us see what happens if I'm coming down. So from this place, I'm going to come down on a westerly heading. So it is 264. And now further west, it is 236. And further west, it is 225. So in the northern hemisphere, if I'm coming on the westerly track, my great circle track decreases. Okay, so now let us go have a look at the southern hemisphere. We'll start with the easterly heading. So I'm going from one point to the other point on the southern hemisphere on an easterly heading. So my great circle track is 49 at this point. Now if I'm going further east, it is decreasing to 41, and further down east, it is decreasing to 40. So in the southern hemisphere, your great circle track decreases on the easterly heading. Now what if I'm going on a westerly heading in the southern hemisphere? Your equator is here. I'm going to go on a westerly heading. So here the westerly heading is 218. Further west it is going to be 221, and further west it is going to be 227, which means if I'm coming on a westerly heading on a southern hemisphere, my great circle track actually increases. So let us recap the session. What are the properties of your great circle? The first property is your great circle is cutting the earth into two equal halves. It will cut the earth into two equal halves. Since it is cutting the earth into two equal halves, your radius and diameter of your great circle is equal to the radius and diameter of your earth. Okay, number 3. The shortest distance between any 2 points is on the great circle. Number 4. Between any 2 points, only one great circle can be there. Why is this? As we know, we are having 2 points, point A and point B. There's a small recap. So the shortest distance will be a straight line. And what is a straight line? A straight line is your great circle. Right. Now, let us see how does your great circle track changes with respect to your westerly or easterly movement. Okay. When you go on the northern hemisphere, when you're on the northern hemisphere, and you're going on a westerly direction, your great circle track decreases. When you go on an easterly heading of the northern hemisphere, your great circle track increases. But when you go as in the southern hemisphere on a westerly track, it increases. On the easterly track, it decreases. To remember this shortcut, you can always write it as DIID. That is, on the northern hemisphere, it increases when you go in a westerly direction. Correction, it decreases in a westerly direction and increases in a easterly direction. In the southern hemisphere, it increases in a westerly direction and decreases in your easterly direction. This is your concept about great circles.